Let us discuss this problem of motion in a two dimension. A particle moves in a plane under a force which is always perpendicular and towards x-axis. Its magnitude being mu by distance from x-axis whole square. Now if it is initially at a distance 2a from the line and projected with velocity root over mu by a parallel to the line, we have to find the trajectory. Just note that the motion is in two dimension and we have x-axis, y-axis to designate that frame, and force is always perpendicular and towards x-axis, and this is stating the initial condition of the particle. It is at a distance 2a from the line and it is being projected with velocity this parallel to the line. Now according to this problem, we would like to draw a picture and then designate how it works. Let us draw a picture of a two-dimensional motion according to this statement. Let us fix these two axes, x and y, and choose the point from where it is projected to be this point, capital A, having coordinate 0, 2a. Okay, so this is projected from this point with a velocity. This is the velocity, and if in between its path the point is here, so the force on it is always directed to x-axis, and its amount will be, the force will be mu by y square, isn't it so? Because y is the distance of this point from x-axis, and it is stated here the magnitude of the force is mu by distance from x-axis, and distance from x-axis is y. So these are the two basic criterias. This is the initial condition at t equal to 0 and at x equal to 0, y equal to 2a, the velocity is x dot equal to root over mu by a. Obviously, since x dot is mu by a, y dot will be 0, isn't it so? So now let us move on to write down the equation of motion. Let us first match the problem which is written here with this figure. I will wipe out the problem and keep this diagram in the below and write down the equation of motion. So let me read out the problem once again. A particle moves in a plane under a force which is always perpendicular and directed towards x-axis actually. Its magnitude being mu by distance from x-axis whole square. If it is initially at a distance 2a from the line, this line is x-axis actually, and projected with velocity root mu over a parallel to that line, that means parallel to x-axis, then find the trajectory. So let us wipe out the problem and write down the equation of motion. What will be the equation of motion? The equation of motion, and let us keep this figure intact. So what will be the equation of motion? Since this is x-axis and this is y-axis, and the force is acting towards x-axis, so it will have no component along x-axis. The component will be along y-axis only. And what will be the acceleration? X double dot or d2x dt2, this is the notation of acceleration, the rate of change of velocity with respect to time, that will be obviously 0, since the force is directed towards this. It will have no component along y-axis, and along y-axis we have d2y dt2, which is same as, which is equal to minus mu by y square. Obviously this minus is coming because it is directed towards the negative sense of y-axis. I hope this is quite logical. Okay, so what will be the first integral? Since x double dot is 0, x dot will be a constant, and to integrate this, or to find the first integral of y, we write this d2y dt2 as, what is d2y dt2? Nothing but this. We write it as ddy of dy dt into dy. This is chain rule, simple chain rule. We replace this dt with dy, and so this is nothing but y dot and ddy of y dot, isn't it so? And that is minus mu by y square. So we have oriented this equation this way so that we may write it as, this equation we replace as y dot d of y dot equal to minus mu by y square dy. We write it as y dot d of y dot equal to minus mu by y square dy. Reasonable, isn't it so? So we wipe out this, and this will obviously give us on integration nothing but y dot square by 2 will be equal to mu by y plus integration constant, because if we integrate this, it comes out to be mu by y, as we all know. Now we intend to apply this initial condition, which states that at x equal to 0 and y equal to 2a, x dot will be mu by a, root over mu by a actually, and y dot will be 0. Now x dot is constant, so dx dt, the value of dx dt will be straight away root over mu by a, since this is constant, it is given. So we can write in place of this constant the value root over mu by a. Quite logical, because the initial value is mu by a, root over mu by a, which is this, it is projected and it has got no acceleration towards x-axis, so it will remain this. Now what about this? We have at y equal to 2a, y dot 0. So if we replace y by 2a, then it will be 0. So the value of the constant will be minus mu by 2a, and so the actual expression will be y dot square by 2 will be equal to minus mu by y plus mu by 2a, as simple as that. And we can replace these two or multiply these two and get this expression. Okay, so what will be y dot? What will be y dot or dy dt? It will be nothing but plus minus square root over this, and we can take the root mu by a to be, we can write it like this, isn't it so? There is a plus minus sign, we can take this root mu separate, and then since mu is common, we are extracting it out, and it becomes 1 by a minus it is becoming 1 by a minus 2 by y. Okay, it is becoming 1 by a minus 2 by y. I hope it is clear up to this point. We have dx dt as this and dy dt as this. Next, we will have to integrate this. Let me wipe this out, and let us write down the value of dx dt and dy dt, the first integrals of the acceleration. So dx dt is nothing but, is it visible clear? Yes. This is root over mu by a, and dy dt is nothing but, see, there is a plus minus sign involved here, and we keep the minus sign simply because the acceleration is directed towards this, and the velocity will also be borne that negative direction, isn't it so? Because the direction of y is upwards and the acceleration is downwards. So obviously the square root plus minus sign will take up the minus sign only, and it becomes root mu into, within bracket, and this is also actually root over which we may write as 1 by y minus 1 by 2a. I hope it was clear from the earlier calculation. And now we will have to integrate these two. So this is quite easy. If we integrate this, it gives out into t plus some constant, since this is a constant. And what about this? We will have to integrate dy by root over 1 by y minus 1 by 2a, and here we have root mu into dt. Okay, and if we substitute y equal to 2a cos square theta by 2, y is nothing but 2a cos square theta by 2, then we do have dy equal to, what will be dy? Sorry, there is a 2a. If you substitute in place of y 2a cos square theta by 2, you can easily gauge that this becomes sec square theta by 2 minus 1, isn't it so? Which is actually tan square theta by 2, and when we take out the root, it becomes tan theta by 2, and the integration becomes actually cot theta by 2, isn't it so? Which is easily integrable. Let us find the dy. Dy is nothing but minus of 2a into 2 cos theta by 2 into half sin theta by 2, because derivative of cos theta by 2 is nothing but sin theta by 2, and we do have here cot theta by 2 and here cos theta by 2, sin theta by 2. So if we cancel, it becomes the sin theta by 2 cancels out, and we have a part which you can easily integrate as cos square theta by 2 d theta, or 1 plus cos theta, and that turns out to be theta plus sin theta, isn't it so? I hope this is clear. Let me do this explicitly. I may wipe this out. I am substituting in place of y 1 by 2a cos square theta by 2. So this 1 by 2a is, just remember this, we will replace dy with this. There is a d theta involved here. So this turns out to be this one minus, this 2 cancels out, and this is minus 2a cos theta by 2 sin theta by 2 d theta. And what we have here is that this 2a and 2a we can take common, isn't it so? So this is root over 2a, because this is in the denominator and this comes out as the numerator, and 1 by 2a cos square theta by 2 is nothing but sec square theta by 2, and sec square theta by 2 minus 1 is tan square theta by 2, isn't it so? So this is actually tan theta by 2. Okay, clear, I think, up to this point. And if we cancel this sin theta by 2 cancels with sin theta by 2 of tan theta by 2, and this cos theta by 2 gets multiplied with the numerator, and this becomes cos square theta by 2, isn't it so? This becomes cos square theta by 2. If we take this a out of the integral, this becomes there is a minus sign, just remember, and this minus I will cancel with the right hand side minus, and we have here 2 cos square theta by 2 d theta, isn't it so? And in the right hand side we have 2 dt, and 2 cos square theta by 2 can easily be replaced by 2 cos square theta by 2 is easily replaced by 1 plus cos theta, and if we integrate this, it turns out to be theta plus sin theta. It turns out to be theta plus sin theta, and the value of x is like this. Then we put the initial condition, which states that at t equal to 0 we have x equal to 0 and y equal to 2a to get the value of this c. And here also, when we integrate this and we write theta plus sin theta here, so it will generate a constant, obviously generate a constant. This dt will be integrated to get t. Okay, so we put y equal to 2a here, and when is y equal to 2a? When theta is equal to 0. So that gives the constant to be 0, and we can replace in place of t this x, so that we have the equation of cycloid as x equal to a into theta plus sin theta. This is the equation of a cycloid. This is the equation of a cycloid. Which is the trajectory of the